Welcome to class, everybody. We're going to be looking at Module 5 tonight, and the topic is arrays and collections. Uh, Kind of an interesting area to start talking about because we've been looking at information as kind of a singular object, right? And we think about a variable or a constant. And aside from the fact that we've learned how to maybe take a string and break it apart, really we still think of everything as like one variable structure in one singular storage spot. And arrays are kind of a natural building block that come off of that, by the way. It's not accidental that programmers developed the structure. And I think this is a really cool image to kind of talk about that, because what we're looking at here is a storage unit for a server that's basically filled with hard drives. This is actually kind of an interesting way to think about how an array works in terms of a data structure for storing information. And if you look really carefully at this picture, now I'm not sure you guys can really see it too well over Zoom, but each one of these hard drive bays in this server is numbered. You guys noticing these numbers right here? Look really, really close. It starts with the number 0, and it tells you a little bit about how computers think and work, because computers always start counting at 0. And here's where it really comes into play when we start talking about arrays. This is basically a hard drive array. So it's one storage unit in a rack, but it holds many hard drives. That's exactly how arrays work in terms of storing variables, regardless of what type they are. We'll also look at array algorithms, like what kind of software or programming techniques we use with arrays, because they're well suited for working with certain types of code. And then we'll also look at this concept of collections, which is basically, a form of an array is really kind of a nice way to think of that as well. All right, let's dig in. All right, so an array formally is a type of variable that can hold a bunch of different values in it at the same time in separate little boxes. So you can kind of think of it as one large box, if you're using that analogy, with a bunch of little boxes inside that all hold basically the same type of thing, right? We can actually declare an array by using square brackets next to a data type. So like here you see, for example, they have integer up on the screen, and following it are a pair of square brackets that indicates we are creating an array of type integer. So in other words, what that array will hold is all counting numbers, and we are naming it numbers. Now this is declaring an array, right? And if you compare that to just declaring an integer, same thing, but this creates one storage location. This will create multiple storage locations. Right now, the number of storage locations is indeterminate. We don't know how many storage locations will be there, but it's capable of holding more than one. The nice thing is we still use a singular name to name the whole object, but in its plural form. That's kind of the general rule in programming, right? Because here we're storing a number, here we are storing numbers, right? And so that's just, you don't have to name it as a plural, but I'm just telling you from experience, it makes a lot more sense that way when you're contending with it and you think of it as, oh, it's this variable that contains numbers, plural, right? That's a good way to think about it. So, all right. Now, if you're wondering, how do you determine how many positions you put into an array? Well, here's an example. And this is kind of a weird way to do things, because we're seeing for the first time the use of the new keyword, which tells you that basically, in terms of object-oriented programming, we are instantiating a new object. This is really a data object is what we're creating, that will have 6 storage positions within it to hold integers. Whenever we say new int square bracket 6, we're creating a new array with integer data type with 6 storage positions. Right. And contrast that with this approach where we're declaring nothing. We're just giving it a name and saying, hey, there's an array coming. We're going to call it numbers. There's nothing in it right now. Everything is null. There's no members to it. There's no data in it. Here, we are creating one of a specific size, but once again, we have not put anything in it yet. We have not stored anything here. All we've done is created it and said, okay, this is a 6-car garage. You know, if you want to think of it like a garage, it's a 6-car garage. So you can store a lot of cars in there, more than that 1-car garage for sure. This portion of it here is what we call the size declarator. I'll be real frank, I've never called it that, but formally, that's what the language will like you to call it. Microsoft probably has a book on it somewhere. And once again, this will hold 6 integer values. Now, we don't have to just tie this to integers, right? We just use integers because that's really kind of a good starting place. But the truth is we can store anything inside an array with the right data type declaration. So any of the data types that we use normally in this language can be applied to an array structure. So a floating point number, a character, a long number, a double number, an integer, a string, you know, then there's like shorts and bytes, and I forget all the different number types there are off the top of my head. But there's also Booleans too. We could have arrays of all those things. All of them would use the new declaration if you're trying to preset a number of spaces. So this would create an array with 100 spots to hold floating point numbers, etc. And that would extend out. This would hold 1,200 values. One thing that's kind of interesting about this is when you declare the size, you are grabbing all of that memory that's running on your computer, right? So I wouldn't declare something with 1,200 positions unless I know I'm filling 1,200 positions, because otherwise it's still occupying memory on the computer. It's something interesting to think about. So it's kind of good to know about how much data you're dealing with before you declare it. So once again, the size declarator thing comes into play here. And what we're kind of pointing out is basically it's a really common usage, by the way, like if you're writing a program where, hey, you know, we're going to write a program that calculates average temperatures. How many days are we doing it for? 100. Let's just preset that as a constant, right? And then instead of hard coding the number here and maybe having to change it manually in 10 places in our program, we'll just use the constant name, and then anywhere we want to refer to that 100, we'll just use the name. So this is a really common usage for constants, by the way. You often see this type of a setup. You know? I wouldn't say that like for simple programs that we might write for class that you really need to do that, but it's a good practice when you're writing a real program. Once again, just for the reason of if that constant appears in your code multiple times, now you can just change it by changing one declaration. It's just a smart way to work. Right? Common use for constants, absolutely. So when you're working with an array, you have to declare its size and data type when you're creating it. The size, and this is important, cannot be changed. Right? So once I have it like up in memory, I can't, you know, change that. It's just what it is. So be careful how big you make it. The data type of the array also cannot be changed. So I can't have an array where I'm storing integers and then I change my mind and now I want to put strings in it. I can't do that. Okay, so real interesting sideline, because I know some of you are working in Python right now, and I don't know how fast you're going through that course, but in Python, you can totally do all those things, right? I can put strings with integers. It just doesn't care. By the way, Python doesn't call them arrays. It calls them lists, right? There's also a list structure in C# that's not quite the same thing, very similar, though, in a number of different ways. When you work with arrays, you do have these multiple storage locations. So here, for example, is our 6-car garage, right? So you can see I got room for 6 of my vehicles to put here, or pieces of data. You notice how we also have what we call an index value or a subscript. Now, I've always referred to these as index values. I know there's a whole school of people that refer to them as subscripts. I've never thought of them that way. Right? So I'm just telling you, from my perspective. But it is appropriate to use either term. But when we have this one data structure here that's named, my numbers, and it has 6 individual storage positions, how do I access those individual positions? That's really what we're talking about here. And we use basically that subscript or index to refer to each position. So for example, if I want to pull a value or put a value in my numbers position 0, so the 20 goes to that position, the index, which is the first position, and stores that value there. Same thing happens with the 30, that's going in position 3. Okay, and notice the terminology here, spoken as my numbers sub-0. Real frankly, I've never used that, but I do know programmers that do use it, but that's never been me. Or my numbers sub-3. I always look at it as my numbers position 3 or position 0. That's how I think about it, but whatever. The index value or the subscript number is important because that's how you access that particular record. It's kind of like, what drawer are my socks in? Well, they're in the socks drawer, right? So the index value for the socks drawer is socks, but maybe that's the second drawer. So it's drawer number 2. But wait a second, drawer number 2 would actually be drawer number 1. And this is kind of an interesting thought too, because we start counting with position 0. When we look at the 6-car garage, the highest index number becomes 5, but the size is 6. Now, you might ask yourself, okay, well, I noticed in those other boxes, there were zeros. Where did they come from? Well, we created the array of that size. When we do that in C#, C# will automatically populate the entire data structure with a certain type of value depending on what kind of data structure it is. So if we're putting in integers, the default value for integers and any type of floating point number is 0. So if you don't put something in and then you access that position to extract the data, you will get a 0. That could be good or it could be bad. Just putting it out there. If you have an array of characters, it's going to put in the character code for basically nothing, which is null, basically in ASCII code. So you can actually click on that if you wish, and that will, of course, open on the other screen. Smallest value of type character, that's the minimum value, and that's the default. If it's a Boolean, it will populate it with false. That's kind of interesting. I guess it's better than true. I'm not really sure why. Any other types of objects that include strings or any other complex object type will get populated with a value from null. I want you to understand, though, that null is different than 0, and it's different than nothing. It's the absence of everything is what null is. It's really a hard concept to explain. If I put something into an array, it's something, whatever it happens to be. If I put nothing into an array, well, nothing is actually something as well. It's kind of an interesting thought, right? But null, in computer speak at least, is basically the absence of anything, which is different than nothing and different than 0. Right? So that's kind of important to know. That can trigger errors in the program if you try to access information like that. All right, so if you start kind of continuing through this stream of thought here, it says we have a size declarator used to create an array of size X. Right, so here we got int, square brackets, my numbers, new int 6. Right, so we're declaring an array of size 6. Subscripts refer to each element, and this is kind of as a point of reference. So if the array is of size 6, the subscripts start at 0, but end at one number less than the size, right? So I make one at size 6, but the last position is position 5, or my number's sub 5. Now, I'm not comfortable saying that, by the way. I'm forcing myself to be correct. right? So, but however you think of it, right? You're always, the last position is always going to be one less than whatever the size is. So that six doesn't translate into position six because we start with zero, but it is one, two, three, four, five, six positions. Look, I can see them and count them, right? So that really, really important takeaway. So now we have a little challenge. Okay? And the challenge is create a program that asks for the donation amount for three philanthropists. Okay, whatever. So your prompt can be, how much money are you giving us, right? That's the prompt. And then we would store it. Now it's putting out another challenge here. Without a loop, ask for three amounts. So you don't want to loop it, right? That was last week. Then print them out and print the total amount. Okay, so what they're basically asking us to do is what? To store these values, but more importantly, we're going to store three of them, and we should probably store them in what kind of structure would you think? I'm glad I'm not playing Jeopardy because you guys would have all had the buzzer that disqualified your answers at this point. Right? It's okay to answer the questions if you want to type it in the chat or just unmute and just speak it. But yeah, I mean, what kind of number is this? Well, it's a floating point number, clearly, right? So we probably would use a double in that situation. So let's bring up Visual Studio. Let's quickly get into new console app, and let's just try to code this really fast. It shouldn't take too long. And let's just call it module 5 examples. Well, actually, they call it try it out, right? Try, yeah. Okay. Check the box this time. I'm gonna go back to the old mode, which is fine for what we're doing. We do need to prompt, right? Now we're kind of given some of this, so I'd be a fool to not copy some of it, correct? And we'll do a console right, so it stays on the same line. Paste that in. And you know what? I already know I'm going to do two more of these, right? So let's copy paste a few. Notice I'm alternating them because I'm anticipating a read line here. Right? And we should probably change these numbers. 2 and 3. Okay. We need a variable to store the values, right? Well, we're learning about arrays, so we should create an array, right? So should it be maybe a double array, right? And let's give it a name. How about donations, right? Versus donation if it was singular. Just to kind of draw the point. Then it's kind of pre-filling the code. I'm just going to go with it and change the number. How many positions do I need to create? Well, 3, right? I need to create 3 positions because I know I'm going to capture 3 values. All right, so now that the array is created, I can capture in the first position of the array and see how it's auto-filling it for me. And I'm just going to let it do it. Spot on. Donation 0 will receive what? Do we want to do any conversions here? Like if we're capturing a floating point number?
Oh, did you convert it to a double and read the line?
Convert to a double. And then we need, oops, see, I arrowed off by mistake and it lost my auto type, which is unfortunate. And what are we going to have it do? Well, we're going to do a console read line, right? And we're going to capture from the keyboard whatever they typed in. Once again, repetitive process. So you see, I was kind of a little preemptive. I left the spaces for it. Yes, it's okay to copy paste. It's not yelling at me, but I really don't want these to go all into the same position. But notice how the first one's going to position 0. The second one's going to position 1. The third one's going to position 2. Right? And start counting with 0 in the data structure. But to the user, it's donation 1, 2, 3. It's one beyond where we sit. Right. Okay. What was the other instruction here? I already forgot. We did that without a loop, ask for 3 amounts, and then print them out. Okay. All right. So putting them on the screen, this should be pretty simple, right? So can I just do a caps lock this on there? Console, right line. And you see what's being suggested here already. And I'm just going to go ahead and accept what it did, but is this what I want to do? I would say no. In fact, let's just put this back a second. We probably want to give them a little bit more output than what we're thinking. In fact, I mean, it says right here, right? So it says donation number 1, donation number 2, etc. So let's do that. Looks like they're totaling it as well. Right. So I guess we should probably do that. But if that's what I'm outputting, I guess some of that's going to be text and I'm going to put it to the screen. I could actually dynamically generate this value, but I'm not going to at this point, but we could dynamically do that. I think I'm going to use string interpolation. I just like that approach. I don't know if you guys are feeling the same way about it, but I think it's a really easy way to get the string on the screen. And I do at this point want to output inside curly's here, basically the same syntax that I would normally use, but what am I outputting? Whatever's in position 0, right? And if I want to format it to currency, how do I do that? Like this. Nod and smile, maybe? Or highly suspect. Okay, nod and smile. All right, that's good. Just double checking you guys are out there and with me. Once again, I'm doing copy paste here. These are also going to increment 1 each. If they told us not to use a loop, if I was using a loop, I would write loop code to handle all that for me. Right. We're doing it all manually. We're also being asked to do a little math. So I'm going to create another variable here. We'll call it, this one's not going to be an array. We're just going to call it total. And we will set it to the value of donations 0 plus donations. Okay. Yeah, exactly that. Thank you, Visual Studio. And then we can do one more console right line. And in fact, we can kind of borrow some of this. Well, I guess we don't really even need to string interpolate here, do we? Or yeah, we do. Okay. Let's just type it from scratch. And so let's just do, I think it just said total, if I remember right. And I don't think there was much else to it. And then what are we going to output here? Total. And that's going to be in currency format. Let's close our double quotes and our semicolon. I think that'll do it. What do you think? Cross some fingers. All right. We're assuming that's correct. But really the grand takeaway here is how to create the array, with a specific number of positions, how to put stuff into those positions, how to extract stuff from those positions, and then, yeah, we can still do math with it. We just have to refer to each position number, and then we can output it. So not really that difficult, right? The only difference is instead of referring to individual variable names here, we're referring to one variable name and a specific position within it. This is a very, very useful data structure if you guys aren't picking up on that. Very commonly used and a great way to conglomerate data together. Do we have any questions on any of that, or anybody have any problems getting it to work? You guys all good?
No, I got a question.
Yes, Victor.
Um, when you, if the array is a double, why do you have to convert it to a double when you declare the other donations?
Right. So yeah, that's a, this is more like maybe like week 2 stuff or something like that. But basically the reason is whenever we type something at the screen, it always comes in as a string, even if we type a number. So we have to capture that string, and then this converts it to the right number format. So if we know we're storing it as a double, we're doing the conversion. If it's an integer, we would convert it as an integer. That would be the answer. Does that help?
Yeah.
Yeah. We don't have to do it on the output. On the output, we're using this special character, which tells us that we're going to drop variables in this format right into our string output. Otherwise, I could, for example, pull all this stuff out and then concatenate, well, I guess I could put a $sign in there and stuff, put in total this way, right? That would be a way to do it too. But the write line command, by its nature, takes numbers and turns them into strings before it puts them on the screen. It kind of handles that for us. Where when it's coming inbound to us from the keyboard, that's not necessarily the case. But anything typed at the keyboard is always a string. Doesn't matter if it's a number, a symbol, or whatever. We have to change it into a number to process it. That's unfortunate, but that's how it operates. Let's move on to the next slide here. Now, one thing that you will notice is as you start working with arrays, it's not uncommon because of an array's repetitive structure that it works really well with loops. And loops are often used to process arrays and more complex data structures because of their repeating nature. They just fit well together. Repeating code to extract and store information in a repeating structure, if you will. Right? They just fit. All right, so we can actually loop over array by basically focusing on the subscript or the index number. So for example, if I was writing a loop that used X as its, index value, every time I'd go through the loop, I could increment up one level, and then I can refer to the correct position in the loop mechanically with the loop. So that we can set the loop to start. Okay, look at position 0 first, then position 1, and it just does that. So if we have a repetitive thing that we're doing, then we can put it into a loop structure and then access or retrieve or store information in that array. Okay, and it says here, what do we know that can increment the variable from 0 to 1, 1 to 2? Well, there's a couple of different things, right, that can do that. Well, a for loop, right, is kind of the one that we go to almost always when we process arrays. Fascinatingly, we can use a regular for loop, or there's a new kind that we're going to learn in just a little bit called a for each loop, which is specifically designed for basically working with complicated data structures. But let's look at how this would operate, right? If I set an index value, at 0, right, to match the starting value in the array position. And then I let it iterate from 0 up until it's less than 3. It will never reach 3, right? Because if it reaches 3, this is index 0, 1, 2. If it reaches 3, it's going to break, basically. And then each time it increments automatically. I mean, you see how the for loop is just built for this. I set the index to 0. I set the ending value to be the same as the length of the array. And then I just let it iterate through, and it will go through. And it says here, for each iteration, we're storing in that particular value, whatever this conversion is. So people are just entering temperatures from the command line, and we're storing it in each array position. Hey, maybe we can apply that to what we just did. What do you think? Well, yeah, okay. Well, that's what comes next. So let's try doing that. I think it's a good example to do it. So I'm gonna go back here and I'm gonna see where my code repeats and then put that in a loop. And that's really easy to spot, right? This stuff is repeating, right? And this stuff is repeating. So it's really easy to figure it out. All right, so if I'm gonna convert that to a loop, let me first, let's just move that down. I'm gonna start typing 4. Now, instead of using the word index, by the way, I don't know if you've noticed, but a lot of loops use the letter I, and it's 4 representing index, right? And that comes from mathematics, by the way. And I love that this is auto typing this, because this is a really great teaching point. Notice how it's like sitting there and it's suggesting, correctly, I might add, as one possible option here, that we iterate from 0 up until the length of donations, which happens to be 3. Now I could hard code 3 in this spot here. It would operate the same way, but the smarter way to code it really is to set it up so it's dynamic. So that way, if I check the length of this structure and I probe it for 3, then I don't have to come down here and type 3. It just does it automatically. Therefore, if this changes to a larger structure, this will automatically adjust. Right, so that's a clever way to do it. There are my curly brackets. And now we're going to move one of these statements in, and then we're going to tweak it. All right, so here's what's going to happen. This stuff is good and all that. However, it repeats. And I have a couple pieces of information here. One would be the number 1 here and the 0 here. Is there a way I could generate that value automatically rather than hard code it each time? Because I'm not going to be able to hard code this. What could I put here in place of 0? Yeah, I would be it, because it's going to start at 0 and increment automatically, right? Well, all right, we could use a little string interpolation here. So let's get that $sign in there. And then right here in this spot, I mean, I wouldn't feed in I, because that's going to be 1. Well, it's going to be 0 the first time, and I want it to say 1. So I would just say I plus 1. Pretty neat, right? So that's dynamically generated. It should be the correct value. And so it should say how much donated, number 1, number 2, number 3. Okay, so, and then this will increment automatically. Now, as we're kind of reading the information in, like I did the math down here for total before, wouldn't it be smarter if I just do the math up here right away? Yeah, it would be much smarter. So I could just say, well, first, let's comment this out. And then I'm still going to declare a double called total, but let's do that up at the top now. And just declare it there. And we still will preset it to 0. I guess I could have copied the whole thing, right? Well, not the whole thing. And now as I go through the statement here, I can just simply take total and add to it whatever the current position of donations is. So we'll keep the total as we're going, rather than write a whole separate equation later. could I have kept that statement and it would have worked fine? Yeah. But I'm telling you, this is probably a better way to do it. I think it's more efficient. So now we have another block of code here that repeats. And once again, you know what? I'm gonna comment it out just so we kind of still have it, right? But basically, we're gonna just take this code and we're gonna, you know what? Let's put it in a loop and output it. So let's just say once again for int, and I'm gonna use J this time, just to use something different. And how long do I want to go? 3 times, right? And do I want to, okay, so now it's suggesting donations get length. Should I hard code this as 3, or could I just say donations length? Right, I'm not sure why I did get length, but hey, is there a problem with this? No, there shouldn't be a problem at all. Why is it suggesting -1? I don't want to get rid of the J either. All right, all right. Trying to get that auto type to kick in, and you know, it doesn't work when you want it to. And it works when you don't. Okay, I think I lost you guys there for a second. You guys have a hiccup with me? Yeah, I had a little hiccup. All right, my recorder's still going. All right, I'm not sure exactly what happened, but hey. And now, oh, this is the wrong, that's the prompt. So let's get rid of that. We want this one. We will alter it, right? Could I do the same thing here? Could I say I +1? Yes, I could.
I'm not seeing your screen.
Okay, thank you. All right, because we lost all the Zoom stuff for a moment there. We're just recording my face. All right, probably a horrific sight on the internet for sure. I am just joking. It is very unsettling when you first see yourself recorded in a video and like trying to like do what we do here in Zoom, and the trick is don't watch your face as you talk. Can't handle it pretty much. All right. So the point was we're going to come up here and we're going to add whatever our counter variable is or index variable is. We're going to add 1 to it to say the right output. And then here, we'll just switch this to J. Start at 0. It'll count up to the length, which is 3. It'll never reach it. Increments once each time. We got 1 console statement. Look how much less code it is. I mean, it's not that much less, but we were only doing 3 iterations. I can scale this up to as many as I want. So if I have an array that's of size 20 or 1,000, this would scale to it. Right, let's go ahead and get this rolling then. So let's hit the button, make sure it still works. So far, so good. I'm going to put in the same values I put in before. You just follow the little patterns on my keypad here. And that looks like the right amount. Right. And it still worked, but we use loops this time to traverse the array structure and really kind of learning a couple things about how the length function works relative to it. The fact that we can take those index or subscript numbers that we're using in the loop and attach them to array structures, either for output of text or for actually storing and retrieving information. It works really, really well. So you see how like those two structures, especially in a loop, can just like coexist beautifully. You know, the data structure that has multiple positions and the loop, which can traverse those positions systematically. So it's a really good combo. All right, let's keep moving. One of the problems that we do have, and we didn't trigger it accidentally, fortunately, is the fact that when we have an array of a certain size, the last position or last subscript or last index value is 1 less than its size. Right, so that's why we get that -1 factor. So like length -1, that's where that kind of came from. Right. Now, here's what's kind of weird about this. If I write code and I make a mistake in my code and I'm working with an array and I'm trying to access a position in the array when I'm running the code, the compiler, and this is kind of the point here, will not catch what we call an out of bounds index. So for example, if I was trying to pull, something out of position 6 on this top one, which doesn't exist, the compiler will let me write the code for it, right? Because there's nothing wrong with the code. The code is written well. It just won't work because it doesn't match up with the data structure. So like in this case, for example, if we're trying to access position 3 here, right? Notice that in this case, it will reach position 3 because we have an equal sign in there and it doesn't exist. So it will not have any red underlines when we're in Visual Studio or whatever coding engine you're using. But when we hit run, it will crash. And this will be the error that it throws, index out of range exception. Right? So that's what we call a runtime error as opposed to a compile time error, right? The error doesn't happen until the code's actually running. That indicates more of a logic problem than a code problem, right? Or, a data structure problem. So that's something you have to be really, really careful of. We call these, by the way, off by 1 errors, and they're kind of common when you're working with loops, right? So here's an example of what would happen. Like you would write the code, Visual Studio, you could copy paste this in if you want, just drop it into Visual Studio and see what it does, and discover that nothing will underline red, even though the logic is incorrect. The logic's on you, right? Accuracy in code is on the built-in debugging engine. So in this case, when you do this kind of a thing, generally speaking, if you're comparing it to the size, make sure you remove that equal sign because it will be off by 1. Right? And we call those off by 1 errors, right? Now, when we actually put an array together and we do what we call initialization, which is to actually put stuff into it, initialize all the positions with the value, you can use what we call an initialization list, which is basically a list of comma-separated values that sit inside a set of curly brackets, right? This is a real common technique. You'll see this technique used in other languages too. So Java uses a similar technique. JavaScript uses a similar technique. Python uses a different technique. Right? So close, but not quite. Python will use square brackets in this situation, not curly brackets. And then to confuse things even more, they do allow for curly brackets and parentheses, but for different types of data structures. So then that's where it gets really weird, right? So when you guys learn Python at some point, or if you ever do, you probably will, by the way, because it's a very pervasive language right now. Just keep that in your head. I say that kind of, especially for those, I know there's at least a couple people in here taking it right now. And you probably aren't this far into the class yet, but man, you might be. And then when you hit this material, be like, you'll start confusing the 2 languages. That's what happens, right? So which way am I doing a list or an array in this language? So just please be mindful. Yeah, comma separated values. So here, instead of saying new with the data type and how many positions, and there's 1, 2, 3, 4, 5, 6 car garage or whatever, if you want to think of it like that. Here, we're just manually inserting the integers and therefore also declaring the size of the array intrinsically, right? We are just doing it. So we just created an array with 6 positions that holds integers, and here are the values all at once. So that's a really good technique, right? Because you can create it, declare it, and put all the stuff in immediately. If you have the information, you can do that. Absolutely. Right. Notice no new keyword in the situation, right? You can only do that when you're creating it empty. Arrays, because of they're basically a complex data structure, do have a field attached to them called length, right? And we've seen this before with strings, and it works just like it does with strings. So it counts the number of, positions or storage elements, and it gives you a finite amount. So when I'm working and creating an array of doubles called temperatures, and I say new double 25, there's 25 empty spots. They have index values of 0 through 24, right? And we'll keep on saying this all over and over again. But if I run the length command on it to extract the value, it will return 25 because that's the count. How many positions? 25 positions. What's the last index value? 24, right? Try to, blaze that in your brain. So if this is a kind of a new concept for you in particular, it can be a little bit tricky to latch onto. Now, we do make this comparison once again that strings also do have lengths, right? So like when we're working with a string, we learn that strings are really collections of characters or an array of characters, right? And it really, that's truly what a string is ultimately. And so when I do like, a hard-coded or predefined, initialized array like this one that's got 3 values, and I run the length thing, I will return 3 with this. So if I look at the size of this, it will say 3. Now, if I have a string and I go, well, there's a C sharp space, that's 3, 4, 5, 6, 7, 8, 9, 10, 12, 14. There's 14 in length. The index values for the letters go from 0 to 13. Right? I know this is like repetition, but you know what? Really important repetition, right? So once again, if you're going to run a for loop to traverse an array structure, don't include the equal sign. You want to go up to the length, but don't include it because then you will get out of bounds. You'll be one off by one error, as they say. Can't change the value of an array. So I can't go in here and put in an assignment operator and say, okay, well, the length was 5, but I'm going to make it 17. No, you're not doing that. It's already set. Once it's set, it's set. Catch on to that piece too, right? There's different structures we use basically to like change sizes, but what gets really confusing is if you're also learning Python. In Python, you can shrink and grow them like nothing. It's like you can just do it. Here it takes a little bit more effort, but you cannot change it by just changing that property. I think we've reached a really good point for a break. So why don't we do that before we jump into the next topic? So it's currently 7:50. Let's come back at 7:55. All right, so now we're going to move on to talk about the for each loop, and start out by kind of reinforcing the fact that when you have an array, you can loop through its contents and you can use a traditional for loop, right? And we did that already. We practiced it a couple times, right? But there is actually a different kind of loop that's actually built for doing this kind of work. Although it has some restrictions to it, right? But it's still very, very useful. And the type of loop is a for each loop. And it's basically like a for loop, but instead of worrying about setting up, like an index variable, setting up an incrementer, setting up criteria for it to run correctly, what a for each loop does is it looks at the array structure as it is and processes each one of the contents in the structure one by one in sequence automatically, right? So the declaration, which originally would be int I equals 0, I less than numbers dot length, I plus plus, turns into for each int number in numbers. So in other words, we're going to traverse the array called numbers, then each individual number inside of it, we will just call a singular number. So there comes this like plural and singular nomenclature, right? And then inside here, this is basically a variable we're using inside here rather than declaring a fresh one. And notice how much easier the coding becomes, because all of a sudden we don't have to make this maneuver inside, it's automatically traversed in the for each statement. Very, very clever and useful structure. So basically, it walks through the entire array, starts at position 0, goes all the way to the last position, which is the length -1, right? Every iteration, it stores the next element in the variable, right? So it basically pulls that in. So in other words, every time through, it'll take this variable that we're creating up here in, the declaration, and whatever position we're in, it's going to store that in that position, then we can use it inside the loop. And it's all automatic and beautiful, by the way. It's because it's very easy to code. So it's very, very useful in programming. Here's some of the catches, though. You can't change the contents of the array when you're using a for each loop. So it's only good for reading through, maybe creating some math and doing like math with it, or looking at what's at the array, or outputting the array, or something of that nature. You can't go backwards through the array. You have seen with a for loop or a while loop, both of those, you can set it up so you actually count down instead of count up. That's possible, right? That's not possible here. This only allows sequential access. You also can't skip any indexes, although there's kind of a hack where you can just skip the even numbered ones or every third one, but that's about as far as it goes. You don't have access to the subscript value, so I never get a chance to look at what position it actually is. I'm pulling the stuff off in sequence, so it is what it is. I'm just pulling it off. Oh, you wanted to know where it came from? Well, that's use the other loop then. That's kind of the answer. So these are things you have to keep in your mind. However, when it comes to processing data, the for each loop is really the preferred loop of choice, especially when you're, let's say, for example, reading a block of information from like a database or a spreadsheet. You have it as a text file, and then your code reads through each line or record or whatever from that data file sequentially. It is a perfect match for that. I don't have to know how long it is. It doesn't really matter, but it will step through every position. And so very, very useful in those capacities. All right. Now this is kind of an interesting little tidbit. It says you can't change the size or data type of an array, right? We learned this already. However, you can reassign the variable, which is an array, to a whole new array. So this is really kind of weird. And then C# will step in and do the garbage collection. Now we talked about garbage collection a little bit. And basically what it will do is it will grab old unused values and discard them automatically. It'll take them out to the trash for you, right? But check the catch here. It'll garbage collect the old array if it has no references pointing to it. So there's nothing in memory that's relying on that right now still being there. As long as that's the case, then if it's freed up, it's not attached to anything, then you can reset its size. Here's kind of the syntax. So if I had an array that I declared with 10 positions, I can later say, I have to use the new keyword though. Well, now it's only 5. So that would be an example. If you want to look at that in terms of graphics to help kind of cement it in your brain, assuming that these extra 5 positions are empty and there's nothing else in the program attached to them or linked to them in any way, then C# will just take them out, put them in the trash. You'll never see them again. Goodbye. Right. Well, they're empty anyhow, right? Why would you keep a full, or why would you throw away a full carton of milk, right? You throw away the empty ones. That's kind of the thinking. But it is possible, the point is to resize an array, but this is how you do it. Maybe not as flexible as you might think. The other interesting thing about an array, because it is a data structure, just a complicated one, you can also use it to pass as a parameter or an argument to a function. So just the way I would send an individual value, I can send the whole darn thing. And here's an example where I have a function that's written that accepts an array as a parameter, and then the loop inside processes it. Right, so you see that, it's received as an array, and then we process it as an array, including the subscript numbers. Another thing that's fascinating is when we write functions and methods, we can use an array as a return type, like we do a string or an integer or a double or any data structure, right? So we can return an entire array. So if you run this function and this one just basically creates an array of doubles and then just returns that to wherever it was called from. Right, so that's a possibility as well. Now, for the sake of time efficiency, normally I would sit down and say, yeah, let's code this. But what I'm going to do here is I'm going to skip over this. I hope you guys don't mind. I want to just kind of plow through the material. Efficiency. You guys are with me? All right. However, if you want a little coding practice, here's a little challenge exercise. If you want, like the brain exercise, basically, to write a true false quiz with 3 questions, use 2 arrays, one's with the questions, one with the correct answers, right? So then you can check, basically the answers, using code. So you can write some if statements, some prompts, etc., and then you check array positions. All right. That would be the how you do it. All right. Now we're going to take a look at array algorithms, so things that we can do with arrays that are kind of interesting. But once again, because every language is a little bit different, this one has some interesting quirks to it. So it's really important to kind of talk through these so you don't fall into an issue or a trap. And you know what? Some other languages have these same traps, and I ran into this. And I forget how I did this in Python. I ran into this issue that I'm about to talk about right now, which is copying arrays and how you actually are supposed to correctly do it. All right, so one intuition that you might have, because I could do this with a regular variable. If I created a regular integer variable, and then I wanted to create another integer variable and take the value from the first one and store it in the second one, I can totally do that. It's totally allowed. However, if I take some code like this, create array number 1 and put, some numbers in it, and then down here I create another array, and then I just say it's equal to array number 1, so meaning array number 1 gets stored in array number 2. Here's the problem. It doesn't really work. This is a really strange phenomenon in this language. This stems from the parent language of C, by the way, which does the same thing. Even though I've declared 2 arrays, what they're really doing is when I said array 1 equals array 2, I took the same memory positions and now assigned those to a new array structure, which is now referring to the same memory positions. So even though I have 2 arrays in principle in memory, they're both referencing the same positions. So I didn't create a copy of the contents. I created a copy of the indexes, is what I did. Isn't that an interesting effect? Very weird. I think it's very weird, right? I don't know why they ever did it like this, but I know where it comes from. It comes from the C programming language, which operates exactly this way. So when we do this, we're really moving the index values from one array to another, but they're referring to the same spots in memory. So if I did actually want to go through the process of copying an array, it would look more like this. So I would create one array, put the values into it, create another array of the same size, which is blank, right? So this is what I'm creating, but they are 2 separate spots in memory. Then I would make the maneuver to copy all the array contents from array 1 to array 2 for this many positions. How long is it? So those are the 3 parameters. Which is the origin, which is the one we're copying to, and how many positions are we dealing with? And then that will individually move all the values over to the new array. So that's the procedure. Pretty weird, right? You got to admit that's a little bit weird, but there is what we call a method built for that called copy. There's another one, right? And this is what happens in programming. Sometimes we have multiple ways to do the same thing. Here's another method that you could use called copy to. And I love the syntax on this one because it's basically set up as array one, copy to array two. And then where do we start inserting stuff? At position 0. Now, this does assume a few things. It assumes arrays of the same size and the same data type, right? So, I mean, those would be givens. Otherwise, the code wouldn't work. Kind of an interesting approach. So you could use this technique, or you could use this technique. Both of those would do that. Another kind of interesting thing that we do with arrays sometimes is when we have these complex data structures that sometimes we want to compare the values inside there to see if the values that we have are the same as the values we want. Okay, so here's 2 arrays of strings. One is named students, the other is named teachers. And you can see just from looking at it, the array contents are identical, right? Same names, same positions are in there. But notice we have an if statement here, and it says if students equal teachers, well, then we're going to write line the same. Otherwise, we'll write line different. All right. However, all right. So, and here's the thing. When we do the if statement, what question are we really asking? It's a really valid question. All right. So this is weird about arrays too. When you use the equal operator to compare objects, you are actually asking if the variables contain the same memory address. Now we go back to that memory addressing issue again. It's not the same as are they the same? It's asking, are they in the same memory positions? And the answer, of course, is no, because they're 2 different arrays. Pretty interesting. So what we're really asking when we say equal here, the students equal teachers, we're really asking, does address A equal address B? And the answer is no. They are 2 separate boxes, 2 different spots in memory, regardless if they hold the same data. Interesting, right? It's an interesting effect. So you got to be careful with that. That's not how you compare arrays and look for equality, right? So really what we're trying to really ask is this, array equality, do 2 arrays contain the same values? Much different than are they the same memory addresses, right? And there is a method that we can use called the sequence equal method that allows us to accomplish this. So take a look at the syntax on this. So here's a little thing. You have to use this library, by the way, in order to use this. And this is the link library is basically one that's typically used for database work, by the way, most often. This, in the mode that we've been working in, that should automatically kick in. But if it doesn't, then you'd switch to the other program creation mode where you're inside the namespace in the class structure. And you would add a using statement at the top saying using system link. And if you're missing that, by the way, Visual Studio will highlight that and give you a fix, and it'll say add missing using statement, and you would say yes, by the way, if we get to that point. But in this case now, here's those 2 arrays again, which we have very clear indication have the same identical content. And then we can check if students sequence equals teachers, and if that is true, which it would be, then it would output the same. So that's one way to accomplish it, right? To really see if the stuff is exactly the same. Otherwise, the only real way to do it, and you can imagine what this method does, sequence equals, it probably opens up each array, pulls the contents out of each position, looks at them and goes, are they the same? Yep, this one's the same. Is the next one the same? Yep, that one's the same. Right. Now, it wouldn't be that hard to write the code yourself, right? Is kind of the point on this. But it would take time and it would be not fun to do. Right. All right. So another thing that's kind of interesting about arrays and really any more complicated data structure is the fact that we have usually a bunch of methods available to us for processing them. So here's one where I can take this method called sum, and notice with parentheses, right? So we just add it to the array. So we declare the array which has these values, and then we just run it in this dot syntax, and that will sum all the contents of the array, provided the numbers, right? And then store it in this variable called total. That's a pretty easy one. If you were to find the average, well, here's the thing that you can do pretty easily. You could take the sum from the previous one and divide it by the length of the array, and that would give you the average. Pretty handy. Now, why they don't have a function that, well, they probably do. I'm just, that's probably maybe just a more practical way to do it, but just to show you that you can utilize that to do the math. There's also these min and max functions, and this is pretty useful too. Like if you're processing a large collection of numbers, you might, okay, so a short list like this, you can look at it and go, aha, 47 is the biggest, -2 is the smallest. Really easy because I can see them all. But what if it's 10,000 numbers? Yeah, you're not going to. So having a max and a min function where the function does it for you, it makes a lot of sense. Once again, that comes from the system link libraries, so that would have to be present for that to work. But those are very useful, very, very useful. There is also this concept of sorting that's built in as well. So if you take something that is orderable, and numbers and strings and characters technically are sortable. Strings are sortable and characters are sortable because they really have numeric values behind them. You guys remember that part, right? So that's why we can sort them. And they're not sorted by like the computer memorizing its ABCs. It's sorted by the fact that they have numeric representation, not the other way around. So you can run a sort command. So if I run array.sort and then drop in the array name in the parentheses, it will take the values and rearrange them from smallest to largest automatically. That's pretty useful, right? So if you had names or numbers or values or whatever, you need them sorted, really quick way to do it. Very effective and very useful. There's also this concept, when you start working with arrays and you start thinking about them in a number of different ways. And, anytime you're working with a more complex data structure, you start to like think about all these clever things you can do with it, right? And one thing that you could do, for example, is you could set up arrays that are parallel. So for example, I might set up one array that contains the days of the week, right, in a list, and then maybe another array that holds which classes I'm taking on that day, and then you could correspond them. So I could say like Monday, I'm taking intro to C#, Tuesday, I'm taking intro to SQL, et cetera, right? Friday, there's no classes. That sounds like a great schedule, by the way. If it only worked out that way every time. Sometimes it does, right? But in this case, we have two arrays. They're the same size, and we're imposing our humanness upon it as to like that there's a connection here. But in reality, they're not actually related programmatically, right? They just happen to be the same size, and I'm making the assumption that intro to C#'s on Monday. That's the assumption. It's not a declaration here, right? But if we were, for example, wanting to make these work together, and here's kind of the grand thing. It's up to us, the programmer, to conceptualize that and connect them through code, right? Not like there's a piece of code that says connect these arrays, but in that, hey, position 0 in the weekday array is the day of the week, and then the position 0 in the class's array is the class that matches that, I would write the code that would make that happen. That's the point. But if you're going to do that, same size helps. Data related helps, right? If you were to sort parallel arrays, right? Right. So for example, take a look at this example here. We have an array of students that are strings and an array of their GPAs, right? We assume that they're associated, right? And then if we want to sort both of those, we could basically issue one command to sort two arrays at the same time with the data staying aligned. We're assuming. Is that what's happening here? This is a good question, because right now, are we assuming that Aaron's GPA is 3.75? Well, we're assuming. We really don't know if we're correct, right? But I'm just going to put it out there. We're assuming that. But okay, so are these in order alphabetically? No, right? Alicia would go first, then Aaron, then Jose, right? Are these in order numerically? No. Right? Should 3.81 should be in the middle and 3.9 should be at the end. Right. Now, what we would want to happen, right, is we're assuming Alicia is 3.81, Aaron is 3.75, and Jose is 3.9. And I think this is what we want to happen. We want to sort it. What are we sort? Are we really sorting on both arrays? That's a really good question. Or are we just sorting first? But if we run this command, I want to show you the difference basically. If we put students first, then we're ordering by students. GPAs will follow. If we put GPAs first, then we're ordering by GPAs and students will follow. Right? And it's just all in the order of the declaration. So if you're sending in parallel arrays for sorting, this is kind of how they're linked together, but it's the first one really that's being sorted. The other ones just matched position by position. I'm going to be skipping over these try it outs, by the way, and I think you guys probably will cheer for that, just so we don't spend time on it. We can get out of here faster tonight. But I do want to talk about them really quickly. So if you guys want to try to code these on your own, feel free. It says create a cybersecurity program that tracks the number of intrusions detected each day of the week. Prompt the user to enter each day's count. Right. And so once again, you can see Monday, Tuesday, Wednesday, Thursday, Friday. Probably make an array with 5 positions that might hold the days of the week, and a different one that holds the number of intrusions. You guys can see that, right? All right. Once the data is entered, list the days and numbers of intrusions, the total intrusions for the week, the average intrusions for the day. They kind of gave us all the code for this up above, right? The day with the highest number, the day with the lowest number, and then you can also use 2 arrays, one to store the names and one to store the intrusions. I already kind of gave you that as a tip. This wouldn't be too hard to code though, right? You guys could see that. But that would be a fun little exercise to try. Let's move on to 2-dimensional arrays. All right. So if this stuff is already feeling kind of heavy or complicated, we're going to take it up a notch now, right? And what's kind of fun about this is really what we're doing when we work with a 2-dimensional array is we're basically building a table or a spreadsheet. It's really kind of think about it. It says the arrays we've made so far are 1-dimensional arrays. They're basically all in one row. It's like looking at a spreadsheet and just taking, row A and pulling it out. One table row. Arrays can be of any data type, including an array of arrays. Okay, well, that's kind of weird, like a table with multiple rows. So this is where it gets really bizarre. So I can make an array that inside each one of its positions holds an array, giving us the second dimension. Isn't that kind of a neat concept? So I create an array. Inside that array, I have an array. Right. And if all the arrays inside the other array positions are the same size, then I'm really creating a structure like this. And then I can refer to any of the positions in that structure very simply by using both index values in the correct order. So this position up here is 0, 0. This one is, well, it depends on if you read columns or rows first, I guess, right? Well, usually you read rows first. So this position would be position 1, 2. All right, let's take a look at the code version of this. So when you do this, and it's going to be multi-dimensional, it's a little weird, but when you declare it, you do this, indicating, well, there's 2 of them. There's a comma separating them, right? So you need 2 size declarators on the other side. So how many rows? How many columns? Pretty interesting, right? Rows and columns. Just remember it in that order, rows and columns, rows and columns. And so another thing that we could do, and sometimes when people code these out, they will code them out like this just because it's easy to see. So here I'm creating 2 rows and 3 columns, and I'm pre-declaring the values. I'm initializing the values using the curly brackets. Notice what's inside my curly brackets? More curly brackets. There's another array separated with a comma from another array. And it's 2 rows, 3 columns. And when you write them out like this, you can actually kind of see the structure. It's kind of neat, right? So that's how you would create it. And then comes the fun part, is how do you process this, right? So if you think about this as being a really important fundamental data structure, especially this 2-dimensional array concept, it really leads you right to like a spreadsheet kind of structure, right? And allows you to store, complicated, coordinated information into one device. The same reason I would create a table to store any kind of information, I can use in programming to store that information in that type of structure. Because most of our database tables, when we start to work with databases, have rows and columns. And most of our spreadsheets, which often generate our data between spreadsheets and databases, most of the information that we end up processing as programmers tends to be in a 2-dimensional format. This 2-dimensional array structure is perfect for it, right? And that's why we focus on it a lot and teach it, right? So when we have a 2-dimensional array, you can think of it as a table. You can think of each position inside of it as an element. There's a row index and there's a column index. And then when we refer to something, kind of like we just did with the single index value, we just do it with 2 row column order. If it helps to make a graphic, you make a graphic, real honestly, because sometimes it's really kind of hard to envision it otherwise. So when this one says scores 0, 1 equals 29.75, where does this go? It would go right here in that position. Row 0, column 1 would then be 29.75. Now, if you are working with this type of structure, very common, by the way, to use constants once again to kind of declare some of the array features, especially if you are consistently referring back to it. Like if you're writing a lot of code that's referring to row this and column that, and having the preset values like this is very helpful. Yes, you could hard code them, but once again, every time you want to change your code, you have to change it in all the spots in the program. But very common usage for constants to do this, and then really common to name them just the way you're seeing. All caps, number of rows, number of columns, and then you declare your stuff just in the same way. Now, the same way that we would use loops to process a regular array, we use nested loops to process two-dimensional arrays. The structures, once again, go nicely together. And notice it says the outer loop controls the rows, and the inner loop controls the columns, right? So if you're looking at something like this, and I'm processing it, well, first let's process row one. Okay, so we're on row one, and then let's go through all the columns in row one. Then we'll go to row two. So the rows is the outer loop, and the columns is the inner loop. Once all of those are done, we go to the third, process all the stuff, right? So nested loops are what we use to do that. For example, right? Now, and there's a question at the top too, that, and you know, if we use regular for loops, right? And here's a really good example of like using those constants, right? So we can use lowercase row to begin our counters, or lowercase column to begin our counter, and then uppercase to hit our limit, whatever that limit is that was preset somewhere else in the program. So the outer one controls the rows, inner one controls the columns. I have been asked by people, could you switch them? And my answer is no. Because we're still starting with the row, and this is just a conception thing, right? Who's to say the row is horizontal? Right? Could be vertical. I mean, honestly, right? I mean, it's just all in your conception. We just think of it that way. So I think it's good to stick with thinking that way on it. But rows and columns, just remember that order. Now, could we use a for each loop to do this instead? We sure could, right? This is pretty weird. What's the difference between using a for loop and a for each loop? And if we're processing the same amount of information, would this actually process a two-dimensional structure? You know what the answer is? Yes. The answer is actually yes. It would actually work. All right. I think we should take another brief break, if you guys don't mind, and then we'll come in and talk about collections to round out all the lecture stuff. So let's take a 5-minute break. So I'm going to pause the recording and we'll return and keep moving forward. All right, so the next topic that we're going to talk about is this concept of collections. And you notice at the very beginning of the slideshow, it was arrays, the methods that we use with arrays, and then collections. And the truth is that in C#, an array is just really one type of collection. In fact, we have actually a collection of collections. It's kind of a nice way to put it. And so when you think of an array, and we learned how an array works, and we've now looked at two-dimensional arrays, and that it's like one named object that can hold multiple values, right? And I think this is really kind of an interesting thought, but that expands to a bunch of other different type of structures that we can utilize, all of which have similarities. Some are, I'm going to say, more important than others, and have very specific types of usages. So we're going to go through, some of this information somewhat quickly, but just to kind of give you an idea of like what some of the differences are between some of these. So the first one that we're going to look at that's different is the thing we call a list. So now those of you that are studying Python, right? And so I bring this up with special note, because in Python, when we start working with array-like structures, the first one you usually encounter is called a list. And not to confuse things, but that one uses square brackets. And here we come into C#, and we have a structure just like an array, and you said similar to an array, except its size increases dynamically, meaning if you are going to be adding values to it consistently, this would be a better choice, right? Because an array can't change size. A list can change size, right? You do have to specify, once again, the data type. This is done a little bit differently here, though. So look at the syntax on this. So we say list, and we use a capital L, by the way, so it tells you the kind of object that it is. And then inside what we call greater than and less than brackets, right? So if you're an HTML person, you recognize those as brackets. We use the data type of integer and we give it a name. And the declaration for creating is similar to an array. So you say new list int and then parentheses. And by the way, when you see empty parentheses like this, that's called a constructor function typically, right? So it says the letter T stands for type and is a generic or placeholder for the data type that you provide, and I think this is kind of an interesting thing. So here, in this declaration, you're not talking about down here. So here we're talking about a list of integers. It could also be strings, or it could be doubles, or booleans, or floats, or whatever data type you want. That's on you. If we want to add contents to a list, we can actually use the add method, and this is kind of interesting. Once again, we would be adding very specific values. Where do they get put? They get put at the end of the array. So if I'm saying my list add 5, my list add 4, -7, whatever, like here we didn't declare any size or any shape or whatever. So basically, what does this look like? If I was to output this, well, the first position would be 5, the second position would be 4, etc. They're just added sequentially to the end of the list. Now, the position numbers, of course, are off by 1, right? But it's still the same concept. We're still putting them in, and we're putting it in sequentially, basically. Now, this is kind of an interesting little thing. It says you can also create a list with initial values using shortened syntax like this. So once again, take a look at the curly brackets that are there, and then whatever values you're putting in separated with commas. In this case, we're building a list of strings, calling it colors, and red, blue, green, pink. Okay, those look like colors to me. But they're inside curly brackets once again, sort of the same way that we would do an array initialization with data. Same kind of approach, right? But you would list it just the way that you see it here with the new declaration and then the brackets. That's just how this data structure works. Now, with this next slide, it says a compile error to try to add different data type to a list. This is called type safety. So for example, if I've declared a list of integers and then the 17.1 tries to get inserted in there, it's going to fail. We're going to get a compile error. It's going to say you can't do that. This is an integer list. If I try to put a string in there, same thing. This is an integer list. You can't mix the data types. In Python, by the way, you can. Don't do that. It doesn't make sense, but you can. Really bizarre language, by the way. All right. So how do we access the elements inside of it? Well, the same way we do with an array. We basically use index values, once again, to do that. And the other thing that's kind of interesting is instead of a length property, we have what we call a count property for the size of the collection. So if I do, colors.count, that's the same as saying length of an array. So this is a variable colors. It contains a list of strings, red, blue, green, pink. The count would therefore be what? 4, right? Positions are 0, 1, 2, 3 for index values, but there are 4 total values. So this value is 4. Very, very similar to an array. The only real difference here, and you notice when we refer to it, we still use the square brackets here. So the syntax in reference is the same. The only spot where it's really different is when we're creating a list. What's the advantage of a list once again? Dynamic in size, it can grow. You can also use a for each loop, like you can with other array type things, to traverse the structure systematically. So here we have a list with red, green, blue, pink, whatever again. And then we're just saying for each color in colors. And then we output that. And notice this is kind of interesting, you know, that we just use the keyword var here for colors, right? And isn't it, this is kind of a fascinating declaration. So why aren't we saying all that fancy list stuff? Because this works too. And why this works is because intrinsically colors has to be a variable because it's allowed to change. It's kind of an interesting thought, right? What if we wanted to add an element to a list, but we don't want to put it at the end? Right? This is a common programming issue, right? So let's say I have the color cyan, but I want to insert it at position 2. So we would use the insert command then. So we'd say insert at position 2, cyan. What happens to the stuff that was already in that position? Well, we just pick it up and move it down one. Just push it out of the way and then make an open spot and put cyan in its spot. Afterwards, of course, the list is now size 5. So if I did colors.count, it would give me a return of 5 as the list grew. We can also remove an element. So notice 2 different ways to do this. We can either remove at a certain position. So I could go in here and remove whatever's at position 2, 0, 1, 2. Green is removed. Then I say colors.remove blue. It doesn't look for position, it looks for the value. And in that case, blue is also removed, leaving us with a list of red and pink. Right, so that's why these are grayed out. This removes at a certain position, doesn't matter what the data is. This removes only the one that has that value placed in it. There's also a remove range method, right? So you can actually tell it to remove like all the values from this index position up to this index position. That's possible as well. Now, one of the more useful, methods, I think, when you're working with a list is this method called contains. And it reads like a Boolean statement, like you're basically saying if colors contains whatever the value is, red, right? If that's true, then we would operate programmatically, and it returns either true or false. And that's why we have if statements here. But that's a very useful one because sometimes, you have large complicated lists that you're working with and you're like, hey, does it have red in there? Okay, yeah, it does. Okay, we're good. Whatever the case may be. And you can just check to see if that value is contained. So that was lists. Now related to lists is this other data structure called a dictionary. And you're going to see how this kind of compares to a list and an array, because it shares similarities with both, but has a unique feature to it. And the feature is basically that instead of using numerically pre-generated index values for the positions, we use values that we choose for the positions. And we form what we call a key value pair. So in other words, all the data has both a key indicating what it is and a value, which is the thing you're trying to store. Okay, so let's just take a look at the structure of this and you'll see kind of what I mean by this. So with a dictionary, what we're saying is that our 2 different key value items, our key is going to be an integer. So that's what's going to keep track of things for us. And then our value is going to be a string. And we're going to call this thing days. And then we make a new one. Here's the whole declaration. Normally that would be on one line in code. Then here, as we're adding the information, we add it in key value pairs. We enter in a number and a day, a number and a day. Notice how this doesn't match up with the 0 of the index, right? Now, the other thing that they're doing here is they are using, and I think this confuses it a little bit because they're using an integer here. That could also be a string. That's kind of a really weird thought, but it is something that you as a programmer would decide. So for example, if the example was like a person's name and email address, right? Their name might be the key and their email address might be the value. It's kind of an interesting thought. And the information travels in pairs like that. So when we're adding stuff, we're adding it as a key value pair and those things are stored together. And then instead of accessing the information based upon, the way that we normally would insert the information, we would access it with the key value pair. Now, in this case, we say days 4, and this only works because it's numeric and it's in sequence. If this was also a string, then this would be a string. That's kind of a really weird thought, right? And this isn't an example of it, right? So entering the dictionary is one key and its value. Keys must be unique, and you can access the value by providing the key. So if I set up the key equal to 2, right? So I have an integer with that's number 2, and that's what drops in here, and then that would go up here and look for Monday, right? So it does work really well with numbers as keys, but that's not a requirement. It says you can also loop over all the entries with the for each loop. So take a look at how this one's put together, right? And it says for each, and we have the key value pair, right? And that's just using it as a generic name. Integer and a string to keep track, and then for each key value pair entry in days. So in other words, for each entry that is a key value pair in this more complicated collection, which is a dictionary, we can traverse it. But this is how we're declaring it, because this is a complicated data type, but that has to be prefaced in front of like the localized variable and the complicated data structure. Now, interestingly, as we kind of traverse the structure then, because we're looking at each individual entry, then we can look separately at its key and separately at its value. Very, very useful. Keeping in mind, the key does not always have to be numeric. It does not always have to be numeric. All right. Now, interestingly, you can use the var keyword here too, and then instead it will still give you the same key value pairs. And I'm going to argue that this is an easier approach, because when we use the var keyword, we can just kind of feed in whatever and it will read through it. Still works with key value pairs. And I think that's pretty powerful. All right. So here now we keep ramping up this example, and they stick with the integer string thing, which is fine. I think it resonates better if you use 2 strings, honestly. But in this example, they are initializing an entire dictionary with one statement. Notice how similar it is to the multidimensional array. But this will never expand beyond 2 values in each. It's always a key value pair, right? They're separated by commas, and it kind of reads like an array of arrays, sort of, but that's not really what it is. It's just that we've gotten rid of the index value, and instead we have some other kind of value here. Now, they're using the number 1, 2, 3, and they're in sequence, and this is why this troubles me a little bit. Maybe a better key value pair example, for example, might be like student ID number and student. That would be a better key value pair, right? Where it would be a more complicated number here. And what's kind of interesting about that is with the key value pair approach, the keys have to be unique. You know, that's another aspect of this, right? Is the keys have to be unique. Right. So you always run into this situation too. Does an entry actually exist? And you can test that in a dictionary by simply, for example, looking to see if it contains a specific key, like a student ID number would be a great example, right? And then if the dictionary contains a given key with that method, then you can actually grab the data, right? Or the key. It doesn't really matter which one you're going for. We have a little try it out thing. Once again, I'm going to skip over this for the sake of time efficiency. But this one's kind of an interesting one where they're saying create a letter counter, ask the user for a word or phrase, use a dictionary to count how many times each letter occurs in the input. That would be kind of fun to code. But here's what my practical brain is telling me. We have a holiday this week, and I'm trying to keep that in mind. So I'm going to actually stop the recording right here.